Hello my dear students, this is the third video lecture regarding mechanics of solids. In the previous video lecture, we are studied about what is stress, what is the unit of stress, what is engineering stress, what is true stress, what is the difference between pressure and stress, etc. Okay, today we are dealing with what are the types of stresses. What are the type of stresses? Okay, the stress can be broadly classified as, that is, normal stress and tangential stress. That is, stress is broadly classified into first one normal stress, second one tangential stress. That is, normal stress is also known as longitudinal stress, longitudinal or lateral stress, longitudinal or lateral stress. Normal stress is also known as longitudinal or lateral stress. Tangential stress is also known as shear stress. What is normal stress means? That is stress acting normal to the surface, which is known as normal stress. Stress acting parallel to the surface, is known as shear stress. The stress is acting normal, that is perpendicular to the surface, is known as normal stress, and the stress is acting parallel to the surface, which is known as shear stress. That is the important difference between pressure and stress. This pressure is acting always normal to the surface only, but stress is acting normal as well as parallel to the surface. Stress is acting normal to the surface, which is known as normal stress, and stress is acting parallel to the surface, which is known as shear stress. Normal stress is also known as longitudinal stress and lateral stress. That is, stress is acting normal to the surface along longitudinal axis, which is known as longitudinal stress. Stress is acting along lateral surface is known as lateral stress. Normal to the lateral surface, that is known as lateral stress. Okay, stress is acting parallel to the surface. When a stress is acting parallel to the surface, which is known as, that is tangential stress or shear stress. Okay, first one, normal stress. Stress is acting normal to the surface or perpendicular to the surface, which is known as normal stress. Then what are normal forces? That is, tensile force and compressive forces are normal forces. Therefore, normal stress is again classified into, normal stress is also known as longitudinal stress or lateral stress. Normal stress or longitudinal stress or longitudinal stress or lateral stress, lateral stress. Lateral stress can be again classified into tensile stress or compressive stress. Compressive stress. That is, stress induced in the member due to the tensile load is known as tensile stress, and stress induced in the member due to compressive load is known as compressive stress. That is, stress induced in the member due to tensile load is known as tensile stress, and stress induced in the member due to compressive load is known as compressive stress. Tensile stress is generally taken as positive, and compressive stress is generally taken as negative. Tensile stress is generally taken as positive, and compressive stress is generally taken as negative. Okay, so stress can be broadly classified into, first one, normal stress, next one, tangential stress or shear stress. Okay, next one, shear stress. Shear stress or tangential stress. Shear stress or tangential stress. In the case of both the tensile and compressive, what will happen? Which type of load is applied in the member? That is tensile force. Okay, therefore stress induced in the member is tensile stress. When force is acting towards the body, then the nature of force is known as compressive force, and the nature of stress developed in the member is known as compressive stress. Okay, both the tensile and compressive are collinear forces. Both the tensile and compressive are collinear forces. But in the case of shear stress, consider a body which is acted upon by two forces, that is F having same magnitude Acting at top and bottom layer. Acting at top and bottom layer. Okay, consider a layer. Consider a section line. Consider a section line. Consider a section line YY. In the previous two cases, two equal and opposite forces are applied along the same line, or otherwise these two forces are in collinear nature. Okay, now one part of the body is in this case, the same force is applied on the body along two parallel directions as shown in the figure. In this case, two forces are applied at the top. First one is applied at the top layer and second one is applied at the bottom layer, two parallel direction. Then what will happen? Now one part of the body tends to slide over. One part of the top side of the body, top part of the body makes slides over the another part. That is, top part is slides over the bottom part. Then what will happen? There will be a shearing effect will takes place when two equal and opposite parallel forces acting which are not in collinear nature. Then what will happen? Then there will be a shearing action will takes place. Then the nature of force is known as shear force. Along YY plane there is a shearing action will takes place, that is known as shear force, and corresponding stress induced in the member is known as shear stress or tangential stress. Okay, corresponding stress induced in the member which is known as shear stress or tangential stress. It is very common. Shear failure is very common in the case of riveted joints. There are a lot of mechanical joints are there, welded joint, soldering, bracing, like that. That is a riveted joint. It's one of the mechanical joint. We can join two parts by a rivet. By a rivet, that is a rivet head. You will detailedly study this topic in machine drawing. Okay, this is a rivet head, two parts, that is equal to 1 and 2. Okay, suppose bottom part is applied by a force F and top part is applied by a force. The same case is happened here. Okay, two equal, opposite and parallel forces which are acting top and bottom plate. What will happen? This plate will move in leftward direction and this plate will move in rightward direction. Then what will happen to the rivet head? That is, the rivet head will damage due to the shearing action. The rivet head will damage due to the shearing action. Rivet head will damage due to the shearing action. That is, it will move towards leftward direction and it will move towards the rightward direction. Okay, that is known as shear stress. Okay, two equal, parallel and opposite forces were applied on the same line. The similar forces is applied in the body along two parallel directions as shown in the figure. Okay, now one part of the body tends to slide over the another part, or shear off or cutting action takes place in this case. That type of stress is known as shear force. That type of force is known as shear force, and stress induced in the member due to the shear force is known as shear stress. Shear stress is denoted by the letter tau. Tensile and compressive stress both are represented by the letter that is equal to sigma. Okay, what is the unit of stress? That is Newton per meter square or Pascal. Tensile stress and compressive stress is represented by the letter that is equal to sigma. Both are longitudinal stress or lateral stress. And shear stress is represented by the letter that is equal to tau. Okay, shear stress is represented by the letter that is equal to tau. Okay, now we can move on the another topic that is known as strain. What is strain? What is strain? It is the change in dimension to the original dimension of the body which is known as strain. Change in dimension to the original dimension of the body is known as strain. Change in dimension to the original dimension of the body is known as strain. Okay, when an external load is applied in the member, consider a body. When an external load is applied in the member, what will happen? It will get deformed. Okay, it will get deformed. The ratio of change in dimension to the original dimension of the body, which is known as strain induced in the member. That is, change in dimension to the original dimension of the body, which is known as strain induced in the member. That is, strain can be broadly classified into first one, that is equal to longitudinal strain. What is strain? Change in dimension to the original dimension of the body, which is known as strain. First one, longitudinal strain. Consider a body. Suppose tensile load is applied in the member. Tensile load is applied. This is the length of the member. That is the width of the member. That is the thickness of the member. Okay. Longitudinal strain means lengthwise dimension, which is known as longitudinal direction. Then strain means change in dimension to the change in dimension to the original dimension. Suppose L is changed to two-dimensional diagram. That is L. When load is applied, suppose this much deformation takes place. That is equal to delta L. Okay. Then longitudinal strain is equal to change in longitudinal dimension to the original longitudinal dimension. What is longitudinal strain? What is strain? Change in dimension to the original dimension of the body, which is known as strain. What is longitudinal strain? Change in longitudinal direction to the dimension to the original longitudinal dimension is known as longitudinal strain. Okay. Second one, lateral strain. Lateral strain. Okay, what is lateral strain? Change in lateral dimension to the original lateral dimension is known as lateral strain. That is lateral direction. What is the lateral direction? Length is the longitudinal direction. Width and thickness are lateral direction. Therefore, lateral strain is equal to delta B by B, change in lateral dimension to the original lateral dimension, or delta T by T. Width and thickness are both are lateral dimensions. Therefore, change in lateral dimension to the original lateral dimension is known as, that is equal to lateral strain. That is delta B by B or delta T by T. Okay. Change in lateral dimension to the original lateral dimension is known as lateral strain. Change in longitudinal dimension to the original lateral dimension is known as change in longitudinal direction to the original longitudinal direction is known as longitudinal strain. Okay. Next one, what is shear strain? What is shear strain? Okay. Consider a body that is equal to A, B, C, D. Consider a body that is equal to A, B, C, D. That is equal to A, B, C, D. When an external force is applied in the member tangentially, okay, which is fixed here, tangential force or parallel force, that is known as shear force. Okay, what will happen? The top layer will slide towards rightward direction. Okay, top layer will slide towards the rightward direction. That is, B is shifted to B dash, C is shifted to C dash. Bottom layer is fixed. B, C is changed to B dash, C dash. There is some angular change will takes place. Suppose that is equal to phi. Okay, consider an element ABCD is subjected to a shear stress on the top face and bottom face. Okay, that is equal to the element ABCD undergoes deformation in different way. Deform, that is equal to ABCD is deformed to A, B dash, C dash, D. Okay, then shear strain that is equal to phi. That is, shear strain is equal to, that is B, phi is equal to, angle is equal to arc divided by radius. That is, phi is equal to, shear strain is equal to B, B dash divided by AB. B, B dash divided by AB. That is equal to tan phi. Tan phi is equal to, tan theta is equal to opposite side divided by hypotenuse. That is equal to B, B dash divided by, tan theta is equal to opposite side divided by adjacent side. Tan theta is equal to opposite side divided by adjacent side. That is B, B dash divided by AB. That is, for small angle, tan phi approximately is equal to phi. Okay, therefore phi is equal to B, B dash divided by AB. That is equal to value is known as shear strain. Okay, that is shear strain is represented by phi, which is known as shear strain. Okay, consider consider an element ABCD is subjected to shear stress at the bottom and top layer. On the faces bottom and top layer, the element ABCD is undergoes deformation and deformed to A dash, A, B dash, C dash, D. Okay, and some angular change will takes place. The deformation is expressed in terms of angular displacement. That is, its displacement, the B dash is represented in terms of the angular displacement. That is, B dash divided by B dash, B is changed to B dash. Therefore, B dash divided by AB. That is equal to, actually, that is equal to tan phi. Tan phi is equal to opposite side divided by adjacent side value. That is equal to B dash divided by AB. That is equal to tan phi. Okay, therefore, for small angle, tan phi approximately is equal to phi, that is B dash divided by AB, that is known as shear strain induced in the member. Okay, strain is generally represented by the letter, small letter E or epsilon. Small letter E or epsilon. Okay, strain is generally represented by the letter, that is small letter E or epsilon. That is, longitudinal strain and lateral strain is represented by E or epsilon, epsilon or small letter E, and shear strain is represented by the letter, that is equal to phi. Shear strain is represented by the letter, that is equal to phi. Okay, thank you.